Hi guys, BuildZoid here, and today we're going to be doing some RAM overclocking, so of 4 sets of this stuff. Come on, focus. No? Come on. Damn it, why are the webcams so crap? I'm pretty sure it's on autofocus, I think. Wait. Yeah, it's on autofocus. There we go. Yeah, so we're going to be overclocking the Crucial Ballistix Sport. Is it just Sport or is it Sport LT? I don't know. I don't really care. It's 3000 megahertz CL15, 1.35 volts. Micron Revision E. We have four sticks of it installed in this Gigabyte Aorus X570 Aorus Xtreme. And yeah, the plan is basically to just go through the process of overclocking this. We are running it in a 4x8 configuration, not a 2x8 configuration, because I've already messed with these sticks in a 2x8 configuration quite a lot, and I kind of want these videos to show the process of overclocking memory, not so much the whole, hey, I remember a bunch of settings that I know work, and I'm just going to punch them in. It's not going to really tell, like, it doesn't really teach you how to do anything. So, yeah, anyway, let's get this thing started. Yeah, we're just going to go through the process with my 3700X here and the Xtreme. And we're using the Xtreme because, well, I don't have a different X570 ATX motherboard from Gigabyte, mostly because I didn't want any of the other ones. Well, it was just like, I'm either going to get a Master or I'm going to get an Xtreme. And then I was like, but I really like the VRM on the Xtreme, so I got the Xtreme. Also, the board is from Gigabyte, so thank you to Gigabyte for providing the motherboard here. And the memory kits I did buy, so thank you, patrons, for funding the purchase of all of the RAM, as well as the 3700X. I'm pretty sure, yeah, I bought the 3700X as well. So, yeah. Anyway, the first post takes a while, so I did clear the CMOS, which is why it's booting up for a while, so... And it's just once it gets through this once, it tends to be a lot faster. And we are on the latest ABBA BIOS, so... Yeah. Oh, great. It put us into advanced mode right off the bat, even though I really wanted it to be cleared. But anyway, yeah, so we're on BIOS version F5B. Yeah, let's get into it. So, well, first of all, we're going to set a static overclock on our CPU. Because I don't want to because we're going to be basically testing performance with IDA, and IDA is CPU bound in terms of its memory tests. So if you're running boost, your CPU's frequency going up and down is going to screw with the results. We are going to enable XMP, and we're also going to hit insert. So this down here, because later on I just want to go from the favorites tab for all of my memory settings. So we're going to enable XMP. We're going to leave everything else on auto for now. We're going to insert our memory timings so that we can access them more quickly from over there. We're going to set 1.38 volts VCore. That is rather high, but we're going to be running high LLC, so it's going to droop all the way down to like 1.33 volts-ish if we were running something like Prime 95. And Ryzen 3rd Gen, like, I actually don't want to get into the voltages for Ryzen 3rd Gen right now because it's kind of complicated to explain. But basically, like, the gist of it is, if you're running a high current workload, you should be running around 1.325 volts. If you're running a low current workload, you can be running up to sort of 1.4-ish, 1.42. If you're running something really light, then you're even looking at like 1.47 volts. Yeah, so we're going to start with that. We're going to insert our SoC voltage because we might end up tweaking that up and down, though in my experience so far that has not been necessary. We don't really need any of the other voltages here. We're going to insert our DRAM voltage because, of course, that one's useful. Termination voltage, I mean, if you're really pushing, if you're really trying to max out your memory, messing with termination voltage can help, but I'm probably not going to bother with that here. Anyway, for the load line, we're going to go high, and for the SoC, we're going to go high again. You could go for turbo as well. Like, the SoC really doesn't put that much strain on the VRM. We're going to max out all of the safety limits because, well, we don't need them, right? We're not concerned about those. And we're going to leave the PWM phase control on auto. There's no point messing with that. So, I think that covers everything I want to change here. So now we need to go over to AMD CBS, and from here we're going to be grabbing FCLK, so we're just going to insert that. We don't need that. We can set the SoC voltage through the other voltage setting. So we're just going to ignore that. UCLK div 1 mode, we're going to insert that. VDDP, we don't need. VDDG, we're going to insert that. And we're going to enable SOC on Core OC mode. So that basically disables power savings on the I/O die. And I think that's everything we need from here. All right, we have everything. We have our XMP, we have our memory timings, we have our SOC voltage, DRAM voltage, termination voltage, FCLK, UCLK, VDDG. Yeah, okay, we got... Wait, there's one more setting I wanted. AMD DRAM controller, and then we're going to disable power down. So this can help with stability, so that's why we're disabling that. Yeah, and at this point we should be good to go and get like a baseline run of our performance. So we're also going to save a profile, which we're going to save over this profile, because I already tried to do this video once and there was a mistake in it really early on. So anyway, save configuration, yes. So obviously, I wouldn't actually run a static overclock like this. Actually, like my CPU straight up doesn't do 4.2 gigahertz in like heavy workloads like Prime 95 or Intel burn test. So I wouldn't actually run this static overclock. But for memory performance testing, we want to run a static overclock. So, you know, the IDA scores are consistent. But once we're done with sort of like once you're done with your overclock and like once you've figured out where you want to run your memory, you should probably go right back to PBO, right? Especially if you're done with your memory stress testing and FCLK stress testing, which for FCLK stress testing, you're actually going to be looking at running some pretty heavy CPU workloads. So in that scenario, it's just like, yeah, you're probably going to want to enable PBO. Like, as soon as you have memtest passed, it's just like go straight to PBO. Because really, we're just using it for performance purposes, because otherwise the performance goes up and down. Now, since we are on a 3700X, we're just going to be running the latency, copy, and read benchmark, because the write speed is limited by the lack of CCDs in this CPU. So let's start with latency. And we are at 3000, we're at XMP here, so we're at 3000, 16, 16, 16, 35. Is it 35 or 36? Doesn't say. Damn it, the packaging doesn't say. Okay, well, it's 30 something. And our latency is expectedly awful, so that's no surprise right there. I mean, we are at 3000 megahertz. Now, we're at 16, 16, 16, 35 or whatever because, you know, the memory kit is spec'd at CL15, but we're at CL16 because on Ryzen, as soon as you go past 2666, automatically the CPU will enable something called gear down mode. And gear down mode is basically it trades a little bit of performance for a bunch of extra stability. So I actually would generally, I would not bother with going 1T command rate. I would just run gear down mode because it's so much more convenient. Like, it is far more stable than trying to get 1T working. And the performance differences aren't that huge. So that's kind of the thing. But anyway, gear down mode, due to how it works, requires even timings. So it's going to, you know, round up 15 to 16 so that it's an even value. And this is true for CAS latency and TCWL, which is CAS write latency. So those two timings, you have to keep them even if you're in gear down mode. But for timings like TRCD, it doesn't matter. So anyway, so right now we can clearly see that our performance results just suck. We're looking at about 43.7 gigabytes per second. Somebody's going to complain about how that's technically 43. Okay, whatever. I'm just going to do 43.7K megabytes per second. And copy is the same thing, isn't it? Yeah, that's about 43.7. And then latency is awful at 76.8. So our goal for latency is to get it sub 70, ideally. So let's get out of here and shut down and restart. Yeah, there we go. We're in the BIOS. Okay, so with Rev E, the thing is that it is kind of like it times rather loose. So we're going to start with like, well, let's start 18 because otherwise it's going to round to 20. 22, 22, 22, 44. And the other timing that tends to be a limiter is your TRFC. You can't really push the TRFC super low. And actually even TRC doesn't go particularly low either. So that's just like, yeah, that's rather annoying. Anyway, yeah, so here's your gear down mode settings. There's your command rate. We don't have to mess with it because right now we're in gear down mode, which we can actually force enable it if we want to. Proc ODT. This, so with second gen, it was basically you always just ran 53.3 ohms. On some other boards, 60 was worth it. But with third gen, you'll actually find that, you know, 53.3, 48, like depending on the settings you're running, it might actually help to run something lower. I think I've heard of somebody actually ending up at like 34.3 with some crazy settings on a set of B-die. And it was like, yeah, that was the only way to get it to post. So anyway, we're not going to mess with any of those right now because we probably won't even have to because this is Rev E and it's really light on the memory controller. It's super easy to run. So DRAM voltage, we're going to go, let's just go straight to 1.4 or 1.5, actually straight to 1.5. Like the thing is like, yeah, you could inch your way up with the voltage, but like it takes more time and it doesn't really, there's no returns on doing that, right? We're going to set our UCLK to be equal to MCLK. Actually, wait a minute. Oh, I'm an idiot. Give me a second. I forgot about that. Silly Gigabyte BIOS things. Yeah, see, your VDDG is it's over here. So now we have our VDDG voltage over here. So 1050. So, and we're gonna go straight for. We're gonna start right at 3600. We're basically doing a nice big 1-2 skip a few. And I forgot to add my system memory multiplier. There we go. Fortunately, there's no way to rearrange the options you add to the favorites tab, so yeah, they're going to be a bit disorganized. But anyway, 3600. This should boot. He says, as it doesn't. The thing is with Rev E, really good sets of Rev E will actually do TRCD 19 at like 4000 megahertz. Really bad, like my set doesn't. And you can actually get, Crucial has a kit that they sell that's 4000 megahertz 18, 19, 19 timings, but it's like crazy expensive. Oh, no, it's board's just making its way through training. Yeah, but that set's like really crazy expensive. So some, you know, if you're at like 3600, like I think for 3733 I already need like 20 TRCD. So, you know, it's just like don't try to push the TRCD too low if you don't like, yeah, if your TRCD just ends up high, then it's just like, well, bad luck. Right? You just got unlucky with the memory kit, and that's kind of it. Yeah, I think we're probably going to end up at 20 for anything above, like much above 3600. Yeah, so that was nice and easy. Yeah, so we've already got 36. Wait a minute. Why is the memory frequency readout really low? I wonder if that side tab is bugged out. Wait. No, nothing over here. Let's just quit without saving and go into Windows. One of the sort of annoying things on Gigabyte motherboards is they will automatically underclock your memory if you punch in a bunch of settings that don't work. And I won't necessarily tell you about it. So you'll get into Windows. Ah, yeah? Okay. Yeah, okay, so it did actually drop frequency. Okay, so that's annoying. Yeah, let's go looser. Maybe it's screwing up the TRFC setting. So the thing is like TRFC on these has to be quite high, so we're going to set it pretty high. might help is also dropping the CLK drive strength to 20. So I've not tested this in 4x8, so that was a good idea, because in 2x8, this would have already worked. There we go. So it looks like it did actually bounce off the automatic TRFC. Like, well, it could have been automatic TRFC, or it could have been the CLK drive strength. Let's see if we can make it to Windows. I don't expect it to be, well... The funny thing with memory is, like, especially with some of the like resistance settings, like the CLK drive strength or proc ODT or some of those, like one adjustment can make all the difference between completely unstable and completely stable, right? Like if you nail it, it's perfect, and any other value could very easily not work, which makes memory overclocking really, really annoying. So anyway, where's IDA? I did also loosen out the TRCD way out, so that could have helped as well. Okay, so we're still getting, yeah, the latency is still god-awful. Which is to be expected because the timings are crap. Well, like, basically, yeah, our timings are actually probably, like, latency-wise, yeah, our primaries are actually straight up worse than what was on auto. Anyway, let's see the read speed. This is where we should pick up a ton of bandwidth just because we have so much more clock speed, though. Yeah, so that's where we picked up, like, 7,000 megabytes per second. Cool. So now we're getting 50.2. For copy. So I think 800 TRFC right now might be completely unnecessary, but I don't expect it to go below like 550 or something. And that's kind of the big difference between Rev E and, say, Samsung BDI, where Samsung BDI at 3600, you can easily run a TRFC of like 260 or 280, or even, like, well, even good kits will actually do even like 220 or something. So you can run a really, really low TRFC on BDI, which this just doesn't do. But, yeah, this is also like half the price. So, you know, it's just like, I don't really... Like, depending on your priorities, you know, taking a, like, because it's memory at the, like, yes, your memory performance is measurably worse, but you got to also keep in mind that, you know, a 50% difference in, well, you're not even going to see a 50% difference. Like, best case scenario, you're going to be pushing, like, 62 nanoseconds worth of latency, right? Whereas we're doing 76. So, okay, 76 is high, but it's not like 62 is like, that much lower anyway, right? That's what I'm getting at. So at this point, let's just keep pushing the frequency up. All right, let's just keep pushing the frequency up and then worry about dropping the timings. So let's go for this. It is worth noting that actually at higher memory frequencies and like more, well, basically higher performance memory settings, so memory settings that give you more memory bandwidth and push more data, lead to worse FCLK stability, just because the FCLK has to do more work essentially. So, hopefully this trains. Yeah, it looks good to me. I'll just check that everything applied as expected. Yeah, we're at 3733. Cool. Wait. Why is our voltage reading so low? That could very well be bugged out. I'm gonna grab my multimeter. And we shall see if I can get it into the shot as well. Okay, if I put it over here, yeah, you can just about see it. So, just... Oh, we are at actually 1.2 volts dim voltage. That's very odd. Okay, wait, we need to fix that. That's a problem. Why? No, why is the dim voltage so low? 1.4. Wait, is it because I have XMP? It could be because that's enabled. Let's try that. Now, I could explain a lot of things if it wasn't applying the memory voltage. Okay, wait. Just gonna do a sanity check. And yeah, it's 1.4. Cool. Okay, so that is new. I've not seen that happen before. So I wonder if it doesn't like 1.5 volts for training. Like, that is actually possible. That it doesn't want to train at 1.5 volts memory voltage. It's kind of surprising because that's a relatively low voltage, but it's not like, it's not impossible. Could also be just some kind of weird bug with the BIOS where it forgets forgets the memory voltage setting or something. I've just not run into that yet. Nah, it seems to be doing the same thing, right? It's stuck on 70 again. This is why having a postcode is useful. Not only can you see that, yes, there's a memory problem, you can also track, like, if I see this postcode, then it means probably this happened. Yeah, okay. Yeah, so it doesn't want to train at 1.5 volts. That's cool. That's cool. We don't need to run 1.5 volts if we can't run 1.5 volts. I mean, right? Like, why force it? Anyway, now we're going to go all the way to Windows and see the performance again. It should just go straight up because we haven't changed the timings. We've just gone up in frequency, so our latencies are down. I don't know. We might make it under 76 now. We might do like 75.5 or something. And we might pick up another gigabyte worth of bandwidth. Maybe 2. Okay, benchmark, memory latency, and start. I like to start with memory latency because this one actually is the one that like tends to crash more often than the other two. Also, if your latency is improving, then everything else has to, like, well, unless you're doing something very odd, then if your latency is getting better, then everything should be getting better. And whoa, we picked up a lot. I wonder if there might have been like a training issue at, like, when it was going down to 1.2 volts, there might have actually like like it could have been training some weird timings for the tertiaries or something. That's a nice improvement just by going to 3733. It could just be the memory. Yeah, and we picked up about 2 gigs worth of bandwidth. So plus 2 gigs on read, and we're going to probably see like plus 2 gigs on copy as well. Oh, copy didn't pick up quite as much as read did, but whatever. Okay, so now we're going to start, like, well, we can still try going for 1900 FCLK. The thing is I don't actually know if this motherboard's capable of it. Like, this CPU definitely can do 1900 FCLK. It does it on a bunch of other motherboards. I've never managed to get it, like, fully stable. But it does boot it. The issue is I don't think I've done it on this board yet. So we'll see if I can make it work. So first we're going to save ourselves a profile. Fast. And then we're just going to go 1900. 1800. No, looks like it will work. Oh no, it got stuck on 70. Come on. Probably lost the voltage again. 9A. 0527B2. There we go. Okay, so we're at 30. Yeah, I lost the voltage. That is so strange. 1.45? I've not run into that yet. So we get to learn something new together, people. Because I've never seen that before. And now it works again. Okay, so that is bizarre. Okay, 1900. Yeah, we've got 1900 up and running, so that's great. All right. Yeah, for some reason, that BCLK readout over there is bugged out. That's bugged. That's why all the frequencies look weird. Also, that voltage reading is from the Super I/O. It's before the CPU socket. It's reading high. Hey, did I just change the BCLK back? Oh, whatever. Oh, now that's bad, isn't it? Oh, no, it's moving. Oh, man. Yeah, I did set it to... Okay, that's strange. I guess it might be unstable due to the spread spectrum when it's on auto. It's funny, on my other motherboards that doesn't actually happen. Or, well, on my ITX it doesn't happen. And that one doesn't have an external clock gen, so... Okay, I would not be surprised if at this point it started crashing. $72.3, cool. Latency keeps coming down, that's nice. Do a read. So the thing is, like, I wouldn't be too fussed about, like, giving up 1900 for stability because, well, at 1866 we were already getting 73.3 nanoseconds latency, right? So it's kind of the thing is, like, 1900 sounds nice, but it really isn't that much of a, like, an actual performance increase. Yeah, so we picked up about a gigabyte on read and copy as well. So let's restart and start messing with the well, start tightening up timings. It's very strange though with the voltages though. Wonder if 1.5 will work now. Oh boy, the capture card is having a... issues. Are you kidding me, Mr. Capture Card? Thank you very much, Mr. Capture Card. That's much more like it, isn't it? Yeah, so we're still at 1.45 volts. Okay, that's good. Because that means we can actually start tightening up timings. So, first up, that 20. Too high. Let's go for... Let's just, you know, 1, 2, skip a few, go for 16. I don't know if it'll work, but let's hope. Go for 22 on those. This will go with 70 to start with. Unfortunately, the BIOS is being extremely uncooperative and not telling us what all of the damn odd timings on auto are. But that's fine. TWR, we can probably run a 12. TCW... Wait, what? Nope. Nope, nope. We're going to go for 16. So TCWL, you normally want to keep it either... Okay, there's basically a range of values that work for TCWL, but tends to be that it's either equal to your TCL, it's 1 lower than your TCL, or it's 2 lower than your TCL. And sometimes you can run it like 3 lower or 4 lower as well, but most of the time it's like equal, -1, -2. And there are some motherboards which are really strange where you actually need like really high TCWL. And yeah, those motherboards are strange. So anyway, then we're going to go for 4.4 for our TRDSNL. We're going to leave that on auto because I don't trust myself with that one. We're going to go for 640 TRFC to start off with. And we're going to go for a TFAW of 16. Also, these SCL timings, let's go for 4 initially. Those make a big difference to your performance. So that's why I'm going to go for that. TCKE of 1. And we're just going to leave everything else alone. Hopefully this works. Hopefully it doesn't forget our memory voltage. So yeah, but at least we've learned that if it throws up a 70, it means it's forgotten the memory voltage and it's not happy with it for some reason. Oh, 5 to... No! Okay, so we're going to have to tweak the memory voltage. It's very strange. I've never run into that before. I should have saved a profile. Hopefully... Oh, no. It's doing 3F. Okay, well, there goes the auto recovery. F9. Come on board. Don't make me do it. I don't want to clear the BIOS. Okay, it looks like it might actually be able to get its way through this. Did we make it? Man. There we go. Finally, it recovered. Oh boy. Oh no. It didn't recover at all. This is freaking garbage. Okay, I wonder if maybe well, no. Let's try 1.35. That is real. Like, I really wish sometimes that there was like just physical switches for voltages where it was like, no, motherboard, you don't get a choice. It's 1.35 volts, or you don't or you don't get to boot. Oh boy. Oh well. So we're gonna go with that, and we're gonna try again the same timings. Let's start with 18 this time. 22, 22, 72, 12, 18, 44, 640. And yes, I'm aware we're at 3733 this time. Actually, let's try 4.6 initially. And also, I'm going to tweak the proc ODT. There. I'm going to start with 53.3. If it doesn't like that, we're going to start working it down. Shouldn't be too aggressive, right? Yeah, this should work. Please don't throw a 70. Yes! Okay, so that is super strange, though, with the voltages. I wonder what causes that. I wonder if it, like, and it's also a shame that this motherboard doesn't have what a lot of, I wonder if it's an Intel-only thing with Gigabyte, because... I can't remember, but the thing is like, at least on some Gigabyte motherboards, you have a memory training voltage option. So you can actually tell the board to, like right now, we could tell the board to do the memory training at 1.35 volts, but then actually run at 1.4 after it's already finished memory training. And that could be helpful for, you know, basically if, like, you actually need 1.4 for stability, but the motherboard, like, the memory controller freaks out if you actually try to feed it 1.4 volts from the get-go. So, yeah, that's interesting. That's very interesting. It didn't freeze. Okay, now we're getting 69.9 nanoseconds. This very well may be actually the limit for this configuration here, because it is Rev E, and well, there's a bunch of other timings to play with, but I don't think we're gonna, like, I think we're gonna top out at like 66, 67, maybe. I can probably knock off 1 or 2 ticks worth of TRCD. Maybe another tick or 2 of TRP as well. Okay, so these are still around 53.5 gigabytes. Somebody's gonna be like, Buildzoid, why are you mashing the delete key when you can clearly see from the postcode that it's not about to get into the BIOS. It's just a bad habit. Okay, so wait, why is our memory frequency saying 4000? Oh, the BCLK is like super glitched out. It says 100. Yeah, no, this CPU would not post at 4.5 gigahertz. I'm sorry, motherboard, but you can forget about that. That's not happening. Okay, 21, 21, 21. See if we can work this down a little bit. And be like, let's go 68 to start with. TWR, let's start 10. TCWL tends to go a bit lower than the cast latency, so we'll try 16 there. TRCDWR, we can actually run 8 on that. Let's see if we can do 20 TRP. That tends to be a thing that is possible on most BDI kits. I mean, Rev E kits. So let's try 600 for TRFC. I don't think it's going to go below that, though. Like, Yeah, that's really... There's a pretty hard limit on the TRFC. Might be able to run 412 for those. RTP, we might be able to run 12 or 11. Let's start with 12. Because I think this one might actually be subject to gear down mode as well. And then for SCL, we're going to try 4, 4, and yeah, changing this many timings at the at once, not advisable, but, you know, we don't want to be here all day. Honestly, if you were doing this yourself, you know, and you had absolutely no idea what you're working with, then you should really, like, inch it down. Like 1 or 2 timings at a time. So I'm going to save another profile at this point. Faster. F10. We're doing this at 1.35 volts. Hopefully we don't need more voltage, because the motherboard seems to have issues once you need more VDIM. 98, OD, oh no. No. Oh no, it's upset. I wonder if it's the SCLs. 0527B2, and it's going to tell us how... Oh, man. I think this is really unstable right now. What'd you say? Oh, boy. That is very strange. Oh, and it crashed. Yeah, okay, it was just super unstable. Okay, so... Okay, it's strange how it manages to reproduce that same, like, state of error as before, but I don't particularly care. Anything higher than 600 at this point. I think it's those 2 timings causing the issues, so... It could be the SCLs as well. But I do distinctly like, from my experience messing with Rev E, it's like the the TRC doesn't go as low as you would expect it to, and the TRFC also doesn't. Yeah, okay, so now those errors are away. It's probably still not particularly stable, though, so 620 seems to be about where we could probably run. Actually, no, let's try 600 again and see, well, okay, no. The better way to figure out if it was TRC or TRFC at this point is to drop the TRFC a lot and see if it, like, stops posting or something. So let's just go straight to 580. Because it could have been a combination of the two, right? Like, if they were both slightly borderline. Also, TRFC is one of those timings that's like the one where you get a lot of performance gain. Just because normally it's so damn high. Oh, 570. Okay, so now, okay, not an... Now it's so now it's going to wipe the voltage again. I expect it to not be stable at all. Oh, man. I don't think it's going to make it into the BIOS at 1.2 volts. Unless it, like, goes into some kind of soft recovery mode again. Oh, boy. Yeah, it is super unstable. Okay, so I think it was TRFC at this point. Yeah, it locked up. It's TRFC. Man, it really locked up. I might be in trouble, because we might not be able to get into the BIOS for long enough to fix the TRFC at this point. There's probably like the funny thing is it's probably like one of the sticks that doesn't like that setting, and so it's like that's why it's intermittent based on like, hey, if most of the BIOS is loaded into some of the other sticks, it's fine. Okay. So I'm actually gonna clear the CMOS at this point. Okay, so with that, my hopes of doing like less than 68 nanoseconds latency are gone, because TRFC is like one of the places where you pick up a lot of, that's where you pick up a lot of your low latency, and it's just like, yeah, that's not going to happen because the TRFC goes below 600 and everything goes straight to hell. Actually, I should just leave it alone, because right now it's going to go through, like, the long post, because we've wiped the BIOS. Yeah, so you can see it's, like, going to be boot looping a few times. That's fine, that's normal. That's what it does every time you clear the BIOS. Okay, which was F4, and we're gonna go faster, bam. And what's nice is your favorites tab does not get wiped when you clear the CMOS, so that's why I'd really recommend you actually set up your favorites tab so that, you don't need to dig around for settings. So it really doesn't like low TRFC. Cool. So I guess we're gonna stick to like 620, and hopefully that's gonna be stable enough. Let's try if we can run like 66 for that. At this point, we're gonna try do an IDA, maybe throw memtest at it as well. I'm kind of worried about how memtest will go. I really wish we could try it. Like, I wanted to cram more voltage into it, because this stuff does scale with memory voltage. It's just that, it's like this board's having some weird issues when you try to raise the voltage. So I wonder if we can try like 1.42. Because I think, like, TRCD, as far as I know, doesn't really scale, but TCL should. So we might be able to run, like, 1620, 120. And my sticks, like, at least one of my sticks really doesn't do low TRCD, so that's, like, why we're probably, like, stuck at 21. Well, I expect to be stuck at 21 right now. Or we can try 20. Let's see. 16, 20, 20. 1.42. I think it was 1.42 that I punched in. No, it doesn't like that. Yeah, see, so I was right. It's 21 for TRCD or no post. Or it might have been... no, it's probably the TRCD. $3,816 isn't that tight. $3,821 on the other hand. For these sticks, well, no, it's not even 3,800. It's 3,733, but still. Yeah, it's doing 3F. 3F is like the worst for recovering from. Okay, so now we're doing 0D, so it might be able to... Well, no, it'll just give us BIOS reset. I'm not going to wait for that. We're just going to power it down, and we're going to clear the CMOS. I really wish that, like, safe boot, like the safe boot button was a standard feature of motherboards. It's the best feature that Asus came up with. And unfortunately, they don't, like, if Asus literally just stuck the safe boot button on, like, their entire X570 lineup from, like, their top-end board to their, like, bottom of the barrel board, it'd be just like, just buy Asus. Because if you want to mess with memory, that button is so helpful. Interesting how it seems to be able to post faster now. Oh no, it's going through the motions again. 0527 B2, come here. Yay! Destroy that delete key. Okay, let's load a profile. Faster. Memory timings. 16. 620. And 1.42. See if that works. Please work. At this point, you might be like, oh, this is why Buildzoid hates memory overclocking. Yep. Okay, so that worked. Nice. And the worst part is, at this point, we're going to run like memtest, and it's going to puke up like 1,000,000 errors per second, and we can just go right back to the drawing board. Well, honestly, what I would do is I'd start backing off the frequency. Because I'm too lazy to try fix one timing at a time. It takes forever. Anyway, let's get Ida. .3 nanoseconds. Yay! 0.3. So, yeah, but I think that's pretty much the limit. Like, you might be able to push 67. But I'm pretty sure we're, like, it's not very likely it's going to do it. Okay, 53. Yeah, so we seem to be hitting the limit of this. I mean, there's still a bunch of timings that I can try tighten up, but the thing is, even on like B-die with proper memory timings, it's just like with the 3700X, I think I've had my read speed tops out around sort of 55 to 56 gigabytes per second, which is just a limitation of how many cores I have, because there's a limit to how much memory you can run through each core. So like the 12-core CPUs can actually do about 60. You know, 60 gigs per second, but yeah, the 8 cores, well, I'm not aware of them doing 60 on 8 cores. But you can do like 56. And this is not bad, right? And plus this is literally like this is half the price of cheap B-die. If you look at expensive B-die, it is like a third to a fourth, if not a fifth of the price, depending on just how expensive the B-die you're looking at is. So let's see what memtest has to say about my settings. I just want to check that I don't have maximum on this. Yeah, okay, I don't. Okay, we have 32 gigs of RAM available, so let's run 28 gigs of memtest. Tell me how bad I am. Windows tab is the shortcut I use to blow it up like this. Yeah, so at this point, I just let this run for a while. Then I'd probably go back into the BIOS and enable precision boost overdrive, which we're actually going to do, because what? Yeah, we still, like, I basically set the limit for these videos to be around an hour, so it's like, well, we're under an hour, so let's go throw PBO at this. Well, more like PBO on top of this. I'm surprised this isn't that unstable. Now, it is worth noting that as memory heats up, it can lose stability because, well, reasons. We're not going to get into those right now. So, you know, if you find that, like, you can pass, like, if your memtest runs perfectly stable, it's not puking out errors immediately, and then after a really long period of time, it does start puking up errors, you might want to look at, like, pointing a fan at your memory sticks, that kind of thing. Yeah, because that a lot of the time, if the errors start showing up later into the test, then it's like, it's just because the memory's got into a temperature where it's unstable. It's actually really funny. I did a test with, well, I did a video where it was like how sensitive is Rev E to temperatures, where I was hitting one of these memory sticks with a hairdryer to see if I could get it to error. And I couldn't get it to error out, but eventually I did that same test with a stick of B-die. Man, that was quick. Like, the moment that stick went over like 50-something degrees, it immediately started spewing out errors. And as soon as you dropped it below 50, it was stable again. Like, literally, if you got it to 50, like, you got it over there was a very specific temperature. You went above it by a degree, errors everywhere. You dropped below it by a degree, and perfect. right? So, yeah, memory, it's not hard to cool. It doesn't pull a lot of power, but it is temperature sensitive to like a kind of absurd degree. And yeah, we're starting to get some errors. So, 2 errors. This might actually be a timing problem because, yeah, actually, wait a minute, it's getting worse. It's still just that window, though. That doesn't really look like a temperature. Yeah, I wouldn't suspect temperatures for this. Because it's not that many errors at once, and it's pretty early. And because RAM doesn't pull that much power, so it takes a while before it gets up to gets hot. So, yeah, I've probably screwed something up. I wonder if it's TRFC again. It could be TRCD as well, but I'd be inclined to think it's TRFC. It might also be that maybe I just need a little bit more voltage. Maybe it might make sense to mess with termination voltage. It might make sense to mess with, like, if it's a timing issue and it's not TRFC, because TRFC is basically just like whatever IC you have plus maybe the volt. Like, you can maybe get lower TRFC at higher voltages. But so a lot of the other timings are like, those are actually affected by like signal integrity. So there it's like maybe tweaking your termination resistances can help, or termination voltage can help. But yeah, TRFC is basically, it like doesn't care for those at all. I'm gonna stop that. And okay, so it's not stable, which is I mean, if this was stable, I'd be very surprised. Oh, and it threw up another error, so it might, well, yeah, there's probably, like, I probably have some timing off, and it's probably TRFC. We could probably loosen it out to like 640. Anyway, so at this point, we're just gonna throw PBO on top of this. So, like, at this point, it's just like dial in the timings is the main issue. And this is the kind of process you would go through for, you know, overclocking basically almost any memory kit. I generally mem test towards the end, not beginning, because if you mem test every step of the way, it's going to take for freaking ever to get anywhere, right? Because if you go up in, say, increments of 100 megahertz, and you stress test every single 100 megahertz, you're going to, like, it's just going to... You know, because you need to let memtest pass to like 400%. So if you're going to be running 400% every 100 megahertz and every, I don't know, timing, like every 2 ticks of timing or something, right? If you're going to be doing that, you're going to be potentially spending like a week dialing in your memory settings. Not really viable, in my opinion, right? So what I like to do is I like to quickly run it up to where it's like, okay, this we can clearly see that at this point it is very much unstable, right? Run it all the way up to the point where it's just like it's blue screening, it's not stable at all. Then start backing it off from there, because if you start backing off from there, you're probably going to find the limit sooner than if you start from something that's very stable and working your way towards unstable, because you don't know when that unstable is going to happen, right? You need to find something that's definitely not going to work as fast as possible and then work back from there rather than working from a safe zone, because, you know, it's like, well, yeah, anyway, I don't know how else to explain that. So hopefully that made sense. Yeah, and I think it really is just a TRFC issue. Because everything else in here looks completely sensible to me, but then again, I'm not the world's best memory overclocker, so who knows? Maybe my settings aren't that sensible. But, like, I'd actually expect this to maybe come down a little bit, this as well to come down a little bit more. What else is there? This might be able to do 3. Some of these are actually, like, especially since we are running a 4x8 configuration, messing with some of the, like, basically from the RDRDSC all the way down to like here, these timings, a lot of them have a lot of impact, because basically this one is like right to right delay, different dim. That's what the DD stands for. So since we have 4 DIMMs, right, that's 2 different DIMMs on one memory channel, so different DIMM. So if we lowered that one, we would expect to see a pretty big increase in write speed, except of course we're on a 3700X, so these are artificially write speed limited anyway, but we could maybe see some improvements in copy. Same goes for like that one's the same dim timing. Different dim again there. I actually wonder if we could run like 4.6 on those. I'm just wondering, right? And also, well, no, we have to keep the CPU settings because otherwise our performance testing is going to be all over the place. It might not post as well. Yeah, so it does not like that at all. Though I'm hoping I don't have to clear. I do have to clear. There we go. Well, video's over an hour now, so I guess I better get a move on. So, yeah, so the tertiaries, if you have a lot of, like, if you have a 4x8 configuration, or maybe like a 4x16 configuration, those can potentially make a lot of difference in terms of performance. They're also very unlikely to tighten up very much, so... Like, it all really depends. Damn it, why does it take so long to post after a clear? B2, please? Yay, it's B2. Okay, so we're going to just load up the profile. Nope, that's not what I wanted. F2, faster. Yes, thank you very much. So, what we're going to do is 1.42. Memory timing's 16. .640, because I really think that was the unstable one. And now what we're going to do is we're actually going to drop the... Just going to put that back to auto. Put this back to... Nope, that back to auto. We're going to put that back to 1.1. We're going to go to CPU VRM settings. We're going to set this all back to auto. Except, like, all of the other ones. We just the main one. And now we're going to go to AMD CBS, performance. Nope, not that one. XFR enhancement. And here we're going to go accept, and that's how we get to our PVO. We're going to set manual. Now, there's a bit of a trap with these. If you do that, it's going to bug out, so don't do that. So instead, we're going to run something nice like... Yeah, I like that kind of power limit. That's a great power limit. What else are we going to run? 4x scaler. Between 1 and 4, you actually do see some differences, but they're not very significant, so we're just going to go straight to 4x. I'm going to set normal. Let's go minus, let's go 0. And I want minus, say, 50 millivolts offset. Because that shouldn't change our performance, but it should give us slightly lower operating temperatures. There was, I think... Was everything in here? Yeah, that was everything in there. Package power limit, manual. There, that's a good power limit as well. I think I'm happy with that. Yeah, I wouldn't use anything in this menu because everything in here is more dangerous than here. And I have another video covering all of that. Anyway, let's save and reset. Okay, I guess we could do a pass IDA just to see how it behaves. We actually might, like, the funny thing is it might actually boost a lot in IDA because it's not particularly, like, it does scale with CPU performance, but it's not particularly heavy. Yeah, 68.5. So we didn't really lose much from the extra, 20 ticks worth of TRFC. Oh, now we're getting 54 gigs. Praise IDA's CPU biased memory tests. To be fair, there's not really anything they can do about that. It's just like, well, if you're trying to benchmark the memory, like the CPU needs to read it or something. So it's always going to be CPU bound. Anyway, I just want to do quick Cinebench. Yeah, that's broken. Why? I think... Yeah, it's custom. Run. Cinebench is not like a great stress test. It's also not a good memory stability, like not a good memory performance test either, especially on 3rd gen Ryzen because these have way too much L3 cache, but it's still like a fun benchmark in my opinion. 2168, that's not bad. Oh man, the single-threaded test takes forever. Honestly, nothing actually runs on one core. So instead what we're going to do is we're going to run 4 threads there. Because that's like a low load workload, so should be getting a decent amount of boost. I'm just wondering what's this going to spit out. If it goes over 800, that's a good score. If it goes under 800, that's, well, that's still normal. Like, normally this ends up being around 790, my experience, so... Yeah, and it is Cinebench, so, the memory overclock probably isn't doing anything. The FCLK might be helping a tad. I wonder what this would get in Geekbench. Okay, 784. Oh well. Standard score. We have Geekbench, so why not run it? Geekbench is also somewhat like memory intensive, so it can actually crash. But Memtest wasn't spewing out piles and piles of errors before, so now that the TRFC's been backed off, I really doubt this won't pass. The issue is, I don't know what's like a good Geekbench 3 memory score for Ryzen 3rd Gen. I've not run it on this yet at all. So I guess I'll just pull up Hardware Bot and see what people are getting there. Oops. Hit the mic. 100X. Go. Geekbench 3 multi-core. Well, 8000 memory score in general is not bad. Like, quad-channel platforms get, like, 10K. 2-channel platforms, you can push, like, 9K-ish. If you're really pushing it, you can get into the 9K range. Actually, I think you can do 10K on dual-channel as well. I think. And 11K, like... 10K is doable on quad channel, like, easily, and then 11K is, like, the upper limits of quad. Anyway, I want to see what other 3700Xs have done on ambient. Oh, there's not a lot of scores. Oh, no. And all of the scores that do exist are terrible. Oh, well. That's that. So, yeah, anyway, hopefully this was somewhat useful for people trying to do, you know, overclock memory on a Gigabyte X570 motherboard. So, yeah, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly, which funds things like the CPU I'm using, as well as all of the memory sticks. Yeah, the other way you can support me is, of course, by just buying merch on Teespring. There's shirts, there's stickers, there's posters. You can find a link to all of that down in the description below, and that does help out immensely. And I've just forgotten if I did the first part of my outro, so yeah, at this point, all that's left is to hit the stop button. Where's the mouse? There's the mouse. Okay. Well, that's it for the video. Thanks for watching, and goodbye.